This gas is so dense and thick, and there's so much of it, that it starts to look like a star itself. It's basically acting like the surface of the sun, except instead of it being powered by fusion of elements in the core, it's being powered by stuff falling into the black hole at the very center. This idea has been around for a while. It's had different names, like a quasi-star. The data do seem consistent with this idea finally. It's this idea that actually goes through all of our seemingly inconsistent data points, and so while it's kind of a spectacular idea, it's the only one that seems consistent with what we're seeing so far.
This is CBS Eye on the World. I'm John Batchelor. Hotel Mars, Episode N. David Livingston, my colleague and friend and co-pilot, joins me now, and we're going far, far away in time and space, mostly in space. We welcome Dr. Joel Leja of Penn State University, part of an international team working on a mystery of cosmology. That means everything. He is a member of the Department of Astronomy and Astrophysics at Penn State, as well as the Institute of Computational Data and Sciences. Joel, a very good day to you as our pilot. You're taking us nearly 13 billion light years from here to the beginning of to the beginning. I don't have to be of what. And you've discovered something that when I first saw it, I think it was a picture in Nature magazine. I thought, they've got to be kidding me. They don't know what that is. I don't know what it is. You called them initially when you discovered them, thanks to the James Webb Space Telescope, little red dots. What did you see? What are you seeing now? And why are there more and more of them the more you look? Good evening to you, Joel.
Good evening, and yeah, thanks for having me. Yeah, these little red dots, I think they've been an incredible story of scientific discovery, and this is what we're all here for. They spotted them in the first images from the James Webb Space Telescope, and they were kind of invisible to previous telescopes, but James Webb picks them out immediately, and they do indeed look like tiny little red point sources, and they're red because they're so very far away that their light has been stretched out and become very red by the growth of the universe in that time. And they're tiny because, well, they are actually very tiny. They're something like 100 times smaller than the Milky Way at a maximum. So these are incredibly tiny systems, and they're very bright, and they've been quite a mystery for us, actually. Quite a mystery.
Quite a mystery, and you cosmologists don't like that. So, what was your first impression? Can you recall, Joel?
Absolutely. I mean, and we love mysteries, actually. It means we're about to learn something. When these things popped out of the first images from James Webb, it was kind of a stunning moment. They look like little galaxies in the early universe, very distant, in the first billion years or so. But they're way too bright, and they're actually too red too. And taking this at face value. This implies mega galaxies, very, very large, near the beginning of time. And It's a little bit like checking in on maybe your baby boy and finding a 40-year-old man. It's surprising to us, and we needed something like 10 times more stars than the Milky Way, but also crammed into a tiny sphere, maybe 1% the size of the Milky Way. And this is crazy, actually. It just doesn't work. It sort of breaks our cosmology, our model of the universe, and it had to be wrong, right? But we weren't quite sure why yet. And figuring out why it took some more data, I think. So the first introduction was quite a whirlwind, and everyone was excited, but no one was quite sure what it meant yet.
So what happened then when you saw it was you took all the considerable learning that it contributed to your education and all of the telescopes and all of the world, and it delivered you to a moment where you couldn't explain it. And that meant you were in an area of, well, it's the best part of a science fiction movie when you're entering into something where nobody's been before. David, you have a question for the doctor.
Yes, Joel. So James Webb goes back about 13.6 billion years, and you have pinpointed, or the research seems to have been pinpointed the little red dots at about 11.9 billion. So, number one, how do you pinpoint to 11.9 billion? And what was going on in the 2 billion years before the little red dots came into existence?
Yeah, well, so one of the big things we're always trying to figure out in astronomy is how far away are things? And on a cosmological scale, when light starts traveling for billions and billions of years, how far away they are will actually tell us also, because the light takes time to travel to us. It tells us how young the universe was when they existed. And so we are trying to measure their distance, and we've measured the distance to many of these objects very precisely now, thanks to the James Webb Space Telescope. And that tells us that these objects, whatever they may be, they've really only mostly lived in the early universe in the first couple billion years. I think the most distant one is when the universe was around 700 million years old, and um, they really kind of peter out around a couple billion years, with the one exception that there is one promising candidate in the nearby universe that is quite rare and may be the exception here. But whatever they seem to be, they seem to be confined to the early universe for the most part, and so that's a big clue, I think, for us.
The theory of time is important here, even though it's arbitrary. If I understand correctly from the literature, they're not supposed to exist. Is that correct? There wasn't time to create a mystery this odd and this commonplace. There's so many of them. So how do we explain them being where they are? I understand there's a range of where they are, but how do we explain that they're there at all with our theory?
Yes. Well, so what are they really? And yeah, one of the great puzzles, as you say exactly, is there are so many of them. For every deep image that Webb takes, Webb finds another one, more or less. And if you were to image the whole sky, there'd be something like 10 million, or probably more, that we haven't identified over the whole night sky. So it's a real surprise that it's taken us so long to find them, if there are so many of them and they're so bright, really. But you needed something like James Webb to crack it. What are they? Why do they exist? So we first thought they were galaxies, and I kind of said already, if they're galaxies, several things are broken, and it's kind of unlikely.
Right.
So
You're doing the Sherlock Holmes thing. You're eliminating the impossible, and whatever's
exactly.
no matter how improbable must be the truth. And you're on your path, Sherlock. Please continue.
Yes. Well, the next big breakthrough, I think, is we got some much more detailed data from the James Webb Space Telescope, pretty fast, and this was a big moment for us. What's inside? And the first thing we found was that the distances are right. As I said, this has been pretty clear. These are early universe phenomena. And the second thing that we found is, and this was the surprise, there was a lot of very hot gas in these systems, and it's swirling around something at millions of miles an hour. And so this is, for people like me, this is a telltale sign, and the light bulb goes off in your head. Maybe this isn't a galaxy at all, but instead it's a so-called supermassive black hole, a black hole that's the equivalent of millions of suns, like the one that lives in the center of our galaxy. And what we're seeing is this very hot gas circling around it very quickly, about to be eaten. And this kind of solves the problem in some sense. These aren't mega galaxies; they're really bright early supermassive black holes, right? So maybe we're done here. Mystery solved. But not really. This is also actually a stunning idea. If we think of them as normal supermassive black holes, like the one we have in our cosmic backyard, other problems emerge. First off, these supermassive black holes, they have to be very big. Tens of millions of solar masses, of suns worth of mass. And, the black hole in our galaxy took the entire age of the universe to get to 10% of that size. So to find things that are 10 times bigger near the beginning of time is they just pop out of nowhere. How? And they also don't really look like other black holes, not in all the ways we expect to find them. They lack other signs of the super hot gas that should be swirling into the black hole, and there's no glowing cosmic dust that we expect near these big black holes. And so maybe they're black holes, but if they are, they're very weird ones. That's kind of where we ended up here. And this was well, I'll say astrophysicists love a good mystery. And there this is one of the premier mysteries, I think, from one of our premier telescopes. And so at this point, there were hundreds of papers coming out, all with different theories. What could these be? How can we explain all of these data? Lots of exotic ideas. It's a very fun time, I think, in the field.
David, you have a question.
Is the black hole star the best hypothesis your team has, or do you have multiple hypotheses? What's the leading hypothesis right now?
Yes, well, there's probably, like I said, there's dozens of different hypotheses. Personally, I have seen one so far that fits all of the data. And that is this black hole star hypothesis. And so the idea is you have, at first we thought these were made of stars, and we got a lot of follow-up data that have signatures in these systems, not just of big black holes, but also of things that look like the atmospheres of stars. We have this dense gas that is, in an astrophysical sense, quite cool. And by astrophysically cool, I mean it's about the temperature of the surface of the sun. Um, but this is a hard thing to produce in space unless it's kind of at the edge of a star, in a stellar atmosphere. And so we were kind of throwing around ideas, well, maybe we do have a supermassive galaxy and there's a gigantic black hole, and these two somewhat seemingly impossible things also live right inside of each other. And that doesn't feel very good. It's a bit of a conspiracy to make up two impossible things and put them right on top of each other to explain something we see. So no one really likes this idea. The black hole star hypothesis blends these ideas in a different way and says instead of a galaxy full of stars, and instead of a normal black hole that is gigantic, perhaps you have one black hole, very large still, very massive, maybe not quite as massive, but it's surrounded by so much gas. The gas that's falling in and approaching the black hole. But this gas is so dense and thick, and there's so much of it that it starts to look like a star itself. It's basically acting like the surface of the sun, except instead of it being powered by fusion of elements in the core, it's being powered by stuff falling into the black hole at the very center. This idea has been around for a while. It's had different names, like a quasi-star. Um, but little red dots, the data do seem consistent with this idea finally. It's this idea that actually goes through all of our seemingly inconsistent data points. And so while it's kind of a spectacular idea, it's the only one that seems consistent with what we're seeing so far. And that doesn't mean we're done. Maybe we'll learn something more, but that's where we are right now. And so we're kind of exploring this idea in more depth. Is it possible?
We're going to give you an unlimited budget so you can go in search of the answers to the questions that you've just raised. But before we go there, I want to understand we're dealing with little red dots in the early universe. Does that rule out that they would exist in our time now and that we should find them somewhere? Or is it only that they would exist in those fields and not in our field?
Yes. Well, that's a fantastic question. And I think we have a working hypothesis for what they are, but we do not yet know why they are. Why are these produced in this way? What is special about the early universe that might create these and maybe in some circumstances allow for this to happen nearby? And this is an area of much speculation. I think my guess and much of the field is leaning towards this idea that these supermassive black holes, they exist at the heart of almost every galaxy. They have to come from somewhere. So they have some sort of life cycle, and at the beginning of time or near the beginning of time, they form in some way. And so this is probably a stage of their formation. Maybe it's an early stage where the universe had much more gas. We were near the beginning of time with the Big Bang, and there was a lot more stuff floating around in space. And so perhaps this stuff can enter a super rapid phase of growth where suddenly we have so much gas falling onto these big old black holes that it starts to look like a star. And well, if that's the case, then perhaps some of these supermassive black holes get started early. And that's what we're finding with James Webb near the beginning of time. It's very common, and perhaps some of them have a later start. They start at a later stage in the universe, and so maybe we'll find a couple in the nearby universe that look similar. Maybe it's sort of a phase of a lifetime, like going to summer camp or something like this. And
I
so,
like that. That's the one that attracts me. Summer camp for black holes. Wonderful. Professor, we give you an unlimited budget. As much time as you want on James Webb for as many years as you want it, or you can build yourself a new telescope. What do you want to do? Thank you.
yeah, well, I think this little red dot story, this is why we do large projects like the James Webb Space Telescope. We always hope to observe something shocking, and that means we are going to learn something new, and in this case, maybe a lot of new things. So these telescopes, these are wonders of the modern world, ships of discovery, and we built them to find things we don't know. Often the most exciting things they see are the things that we didn't know we didn't know, like the little red dot. So I think this is just a really great question. What kind of major capital investment can trigger the next great surprise? Um, and so I think in my field in the past, in astronomy and astrophysics, telescopes so far, they kind of let us go farther and farther back in time by seeing more distant objects. And so that ends at some point when you reach the edge of the observable universe. And James Webb, the James Webb Space Telescope, can already reach that effectively. They can already see any bright thing at the beginning of time. I mean, the most distant galaxy right now that we can see existed when the universe was 290 million years old. That's, sharks have been along for longer than that. It's incredible. So I don't know if we need to go farther back in time yet. The thing that I would be most excited about doing is, well, one of the things we really hope to see with the James Webb Space Telescope is the very first stars. They're unlike any stars that formed subsequently because we didn't have any heavy elements at all at that time. We didn't have oxygen or carbon or nitrogen. None of these things exist. Just hydrogen, helium, and a few trace other elements. So these first stars, they're just out of the reach of the James Webb Space Telescope. We need something that can go just a little bit deeper, maybe a factor of 5 or 10 deeper. And so, if I had an unlimited budget, I would love to take something like James Webb and make it go a little bit deeper to see these very first stars, not just the first galaxies, but the first stars that came before them. And so something like the James Webb Space Telescope, but maybe 3 times as big, and James Webb is already big. But I think that's about what we would need to directly see the formation of these incredible population three, they're so-called population three stars, the first stars ever formed, and they should have dramatically different properties than any other star that has formed since. And that's one of the big questions we have lined up for what's happening at the beginning of time is how did we go from a featureless universe of gas to galaxies full of stars? This is a missing link that I personally would love to see. So we'll take this incredible project and do it again 3 times as large, and I think that's about what we would need to see these directly. I would be incredibly excited about this.
Joel Leja, the Dr. Kiko Miwa Ross, mid-career associate professor of astrophysics, Penn State University, astronomy and astrophysics, as well as the Institute of Computational and Data Sciences, Little Red Dots, David Livingston, Dr. Space of the Space Show. This is Hotel Mars, Episode N. I'm John Batchelor.